We have the third paper. We have the third paper from gauguim on fluidity and the gap in engineering education by Professor Kalisa from Turkey.
Thank you, Mr. Chairman. And I want to thank the organizing committee. And what I will do right now is to share with you some of the questions that I faced in the last 10 years on education. Education in a changing world. And then I'll give you some historical changes that happened because of new machines that came into the society. And I'm from right now Piraeus University. Piraeus is the old capital in the Ottoman Empire, and it's located in Istanbul, very, very close to the shipyards. The next slide will. Next one. We'll give you the objectives. Is in fact to share some of the information and questions I had during the last 10 years on engineering education. Specifically, these things are more relevant maybe to the North America. Next one. I'll give you an observation in 1984 for mechanical engineering, and they look at the written, verbal, and analytical skills of the graduates, and they found it rather interesting that they are doing very well in the analytical field, average or higher, but the verbal and written communications were in the average or marginal case. So that they start thinking about what are we doing wrong, so our engineers are not doing very well. And then when you look a little bit later in 1984, the University of Michigan study on the additional courses recommended for essentially shipyard professionals. They said the first year they should take a course on composition, public speaking, technical writing, production. Second year, third year accounting, business writing for engineers, planning, and fourth year production engineers, management and supervision for engineers, and finally the fifth year courses in design. And a little bit later, in 1996, in Shipbuilding Technology and Education, as the National Academy Press, as a conclusion, they said that in addition to math, physics, and chemistry, the students should be exposed to ideas on shipping systems, operation, finance, government regulations, and other non-technical subjects, and more attention should be given to the development of communication, again, social skills, social and economic studies, business and management, and design. Development of the system thinking and analysis with the technical research and process simulation. So you see immediately that they are able to observe that some of the things that we take for granted are not sufficient to be a good engineer. Now, this is the plot that I have seen in 2001, and it shows a comparison of the preparedness or readiness of the student and the value to the community or the company employment. Now, the biggest gap that I would call that a gap is this is the value to the company, and this is the readiness of the student. In teamwork, there's a big lag, and in product system design, there's a big lag. Leadership, unbelievable difference. Integrative thinking, again, a big gap. social, ethic, and environment, it's definitely not sufficient. Math and science, they found in North America, that's acceptable. They are ready for the demand. And of course, again, the market environment, social sciences, there's a big gap. So anytime I use the gap, please think about the difference between the preparedness or readiness of the student and the value to the company. Now, in 2007, we find that there's a difference in expectation between a traditional engineer and modern engineer. Now, traditional engineer is seen as a problem solver, and modern engineer is problem finder and solver. So it's not enough just to solve the problem given to you, you have to find the problem. The second one, an excellent mastery of technical skills. Now, the expected thing is a combination of technical skills and soft skills. Soft skills in the sense of communication, leadership, and so forth. And the traditional engineer is expected to understand technical context of the work, but the modern engineer is expected to understand the market as well. So essentially, it's a little bit changed, and maybe this is rather interesting. A traditional engineer reports up to the management chain to an MBA, but modern engineer hires an MBA. The next one, I will also show you the modern content of the courses required by the new Canadian accreditation criteria, and there are 12 of them, and the next slide will show the definition of that. So in any course, students are expected to have a knowledge base for engineering. That's we know that that's important. The problem analysis, that's normally not done to the same level that is expected. Investigation, and just you go do things outside of the course, and then there must be a design content, and then the student must be exposed to engineering tools. The student must learn how to work as an individual by himself, as also by team, communication, professionalism, impact of engineering on society and environment, ethics and equity, economics and project management, and of course the lifelong learning that you have to know not only today but follow the technology. We can pass that. Yeah. So then the next question is, what really happened? What is the source of that gap, and how can we essentially fix that? I will outline my observations to you. And the thing that I saw first is that quite a few things happen in nature of technology. The first one is, if you can remember, Sputnik is the first satellite that was put in space by the Soviets in late 50s. And as a result of that, there was a big change in the education. A large number of courses on math, science, and advanced subjects were added to the engineering curriculum at that time. And then I think most of your professors, including myself, was exposed to that type of curriculum. But there were other machines that changed the world. Definitely internal combustion engines changed the world, cameras changed the world, and of course that's our new friend, computers changed the world, and also the education. Now I look a little bit at the impact of the internal combustion engines so that you have a perspective. Of course, internal combustion engines changed nature of farming, transportation, the city, suburbs, started new industries such as tourism, driving, and about 40% of the U.S. economy currently depends on cars. Now, if you look at the bigger picture, then of course in 1850s we had lots of sailing ships, and military ships were also used sails, and nowadays the modern trend is container ships and submarines. Of course, submarines are not possible if you don't have a internal combustion engine work on it. And this education of the captains, of course, is right now done, as said before, by the computers. Now, if you look at the agriculture, this one's the picture. You use horses and you sow by hand. And, of course, new technology came with tractors, but the main impact is that if you go back, I'll explain something. Okay, so the main impact was the fact